Okay everyone, in this video what I'm going to show you is how to run a correlation and a partial correlation. So again, I'm going to set up a new script. I'm going to just with control, or I can also just save it this way, save as, and call it 05 correlation. Okay, I made this earlier, so I'll just override it. And like we did in previous other videos, we're just going to link it to our setup file, so that if we run the script in its entirety and we just want to run the script, it will make sure to load in our packages and our data frames in case our environment is clean. Okay, so link to our setup file. Same old jazz, just type in source and the name of the file you want it to link it to. Okay. Alright, so now we can run our correlations. Right, so I'm going to type in, create a section label called correlation. Again, you can just use comment, hash and comment here. And, there. I'm going to, the function that we're going to use is called core matrix. If I use quotation mark or question mark before it, give us information from it. It comes from the JMV package, right? So that was the package we loaded in, the very first package we loaded in called JMV. And again, it gives you an information about what it does. So it's a way to examine linear relationships between two or more continuous variables. It gives you the usage or the kind of instructions for how to use it. And it gives you information about what each argument does. But in kind of basic kind of what we'd want to use it for is the kind of basic matrix would be, the syntax would be something like syntax core matrix data, this one here, equal to our data frame. And then vars means the variables that we want to correlate. That would just be vars equal to vars v1, say v1, v2, v3, whatever we're correlating together. And that would be our basic syntax. Now we can make this a bit more complicated, but that's our basic syntax. So what I'm going to do here is just, I'm going to copy this and paste it here. I'm going to comment this out so that if I run this code in its entirety, that I don't run this, it would cause an error. And I'm just going to mix and match our variables. So we're going to look at the well-being df data frame, and the variables I'm going to put in are, let's say I'm going to look at well-being, well-being and depression. So look at well-being and depression. And I can run this. And what we have here is a correlation matrix which gives us well-being times depression. It doesn't the matrix size, so it won't duplicate values, but you can see that there's a negative correlation between well-being and depression here, and the p-value indicates that it's statistically significant. Okay. Now let's talk about how we can use this function to kind of give us more information. So if we look at the arguments, we can specify which type of correlation to run. So we can see here it does Pearson's OR. So Pearson is true by default, and Spearman and Kendall is false. So if I wanted to run a Spearman correlation instead of Pearson, I type in Pearson here equal to false to override the basic usage, or the default use of this package, or this function I should say. And I can set Spearman equal to true. And if I run that, it does the same correlation matrix, but this time instead of doing Pearson's OR, it does Spearman's row. If I set both to true, it'll give me the values for both Pearson's OR and Spearman's row. Right? So we can put in both. In this case, I'm just going to keep the default. So I'm going to get rid of Spearman, but you can put that option in. Okay, we can provide significance levels. We can put in plots. So I'm going to do that first. Right? Plots. Set that to true. what that will do is it'll generate a scatter plot and a line of best fit for well-being times depression. The reason why there's a large white spaces here is that we can put in more information into this plot. I'll show you now in a second. So for example, I could put in plot dens, put that to true. That would draw a density distribution between the well-being for well-being and for depression, the shape of their scores or their histogram. I could put in, if we look back to our help, there is plot stats, provide statistics in the correlation matrix plot. So if I do plot stats, equal to true, what it does is it gives me also the correlation value, in this case the Pearson's R, between well-being and depression. So what we have is we have a scatter plot of the relationship. We have the distribution of scores for well-being, the distribution of scores for depression, and we have the correlation statistic. And again, if I wanted to export that, I could by clicking the export button. Okay. Now, other things we can do as well, we can indicate confidence intervals. So if I type in here, type in CI in lowercase and set to true, it will also provide confidence intervals for the correlation if you want it. One thing here, I think it's currently an error in the package. It will probably be fixed relatively soon. They tend to be fixed, but there is a function called flag, like the flag significant correlations. So the idea being that there would be an asterisk here to indicate that it's statistically significant, and ideally 3 because it's less than 0.001. If I type this in, and set it to true, it does indicate it down here, and there's an indication in the plot. It's just not in the table at the moment. I don't know if that's a current error or bug in the package, but I'd imagine it'll be fixed soon, but just in case you were wondering. Okay, so that's how to do it. But with this, that's how you do it with 2 variables. If I wanted to do it with more, then I can just add in more variables here. So let's say I want to add in pain and fatigue. I can do that. Pain and fatigue. I just change what I'm putting in the variables part. If I run that now, it'll give me that correlation matrix, and the plot becomes much more densely distributed. So we can see that's the well-being depression scatter plot. This would be well-being times pain. This would be depression times pain. This would be well-being times fatigue, and this would be depression times fatigue. And I just realized I'm cutting out a bit of the screen, so it might be there, but you'll see it if you run it on your own plot. Okay, so actually what I might do, see if I can move this. That's it here. Okay. Alright, so that's how you do just a kind of correlation matrix or correlation between 2 or more variables. If you wanted to run a partial correlation, so look at correlation but also control for a variable, so I'm going to partial correlation. Just in case you're wondering how I'm getting up the section labels, you don't have to do it the way I do it. You can just type in the hash symbol. It's just Control Shift or Command Shift or if you're on Mac. So I'll just put that here. Control Shift or Command. Alright. To do that, we're going to use a function called core_part. So again, core_part. It's part of the JMV Jamovi package, and basically it's relatively similar to everything we've done so far. It's just all we have to need to indicate is whether which variable we want to control for. So we have controls there. So to do this, just type in syntax part data equals our data frame, so this would be syntax vars equal to same as 4 v1, v2, v3, and then controls being vars, and the variables you're controlling for, v1, v2. That's be the basic part of it. So if we take that, I'm just going to copy that here and leave it here as syntax, just so it kind of remind me how to use it. And I'm going to put in well-being underscore data frame, or df. The variables I'm going to put in, let's say well-being and depression, but I'm going to control for the influence of pain. So I want to know, is the relationship between well-being and depression still significant after you control for pain? So if I press enter here, what it has, it'll give me that partial correlation, and again it will do so, it'll give me a note that this correlation was computed while controlling for pain. So if you look at the difference, I think up here well-being depression was minus 0.533, and here it's minus 0.50, round up 1. So it hasn't really made much of a difference. It's still a statistically significant correlation, but that's quite large. If I wanted to add in more information, I can, for example, one thing we can specify is a hypothesis, and you can do this as well for core matrix. All this does is it allows you to specify whether you're expecting a positive correlation or a negative correlation, right? Or the default would be hypothesis correlation, which just means that it's a two-tailed hypothesis. So I could put in correlation. Oops, don't know what happened there. Correlation neg. Oh, what's gone wrong there? Oh, sorry. Hypothesis equal to negative. So it's just specifying that I expected a negative correlation. It hasn't really changed the result, but that's how you could do it. And in terms of other things you can do, is if I wanted to display this result as a table, you can see it down here. What I can do is save this to a variable. So this correlation, run it here, and then I can create, so this, put this as a data frame by saying as data frame results times matrix, which basically means run the results and give me this matrix, but put into a data frame, and it will do so here. Again, this is more advanced stuff. It doesn't look that useful now, but it would be useful if you wanted to automate processes in terms of running your results and extracting them later and then automatically displaying them. You probably won't be needing that for now, but just to show you that as you go along, that would be how you would start to think about automating your results or pooling results together. Okay, so for example, if you were doing multiple correlations, you could put them all into one data frame, the results. Okay, so that kind of concludes us for correlation and for these set of videos. What we're going to do next week is we'll look at running a between subjects ANOVA, we'll look at mediation and moderation, and we'll look at regression. And one other thing that we're going to cover next week as well is R Markdown, which is a tool for allowing you to write reports in R and combine text and code and results and figures and output. So we'll do that next week. So that concludes this session. Thanks very much, guys, and I'll see you all on Wednesday for our final session. Thanks.